So that's the empirical formula, not the molecular formula. They're not, sometimes they're the same, but sometimes they're not. The molecular formula is always going to be a whole number multiple. The ratio is the same, but some molecules have more than the lowest whole number ratio of atoms. So in order to find out what the molecular formula is, we need to know what the molar mass is, the actual molar mass of the compound. The only way, well, not the only way, but one way to do this is to use a mass spectrometer. Okay, that's beyond the scope of this course. So in Chem 3A, the molar mass will be given to you, okay? There's no way for you to figure it out. To find that whole number that multiplies the empirical formula, we're going to take the molar mass that's given to us and divide it by the mass of the empirical formula that we have figured out. Okay? We're going to find out how many of these fit into the actual molar mass. Once we get this n, we're going to multiply all the subscripts by that to get the molecular formula. So let's do this example. The empirical formula for fructose is CH2O. It's actually one we did earlier. Its molar mass is 180.2 grams per mole. What's the molecular formula? So this is the molar mass of the compound. This is the empirical formula. So let's figure out what's the mass of the empirical formula. We calculate the same way we would do any molar mass. We've got 12.01. There's 1 mole of carbon and 2 moles of hydrogen and 1 mole of oxygen. So 30.026 grams equals 1 mole. Or you can write grams per mole. So if CH2O was the molecular formula, the molar mass would be 30. But it's not, it's 180. So how many times bigger is 180 than 30? It's 6. I mean, we can kind of do that in our heads, but we should write it out. So to find how many times bigger, that's the n, we're going to take the molar mass that we were given, 180.2 grams per mole, and we're going to divide it by the mass of 1 mole of the empirical formula, 30.026 grams per mole. And the units cancel out because this is a whole number. It's not, doesn't have any units. So 80.2 divided by 30.026. This comes out to be 6.001 for blah, blah, blah. This number should always come out very close to a whole number. If you got 6.5 here, that means you did something wrong in the calculations. It's not like the previous example where we had to multiply to get whole numbers. You should never have to do anything to this number. So this is 6. Just get rid of that. That's 6. So what that means is that I take this empirical formula and I multiply all the subscripts by 6. I write it this way just to help you understand what I'm doing. This is not the proper way to write the formula. So the subscript on the carbon is 1. I multiply that by 6. The subscript on the hydrogen is 2. I multiply by 6, I get 12. And on the oxygen, it's 1, and so that's a 6. This is the molecular formula. A molecule of fructose has 6 carbons, 12 hydrogens, and 6 oxygens in it. The empirical formula, if you take 6 to 12 to 6, that lowest ratio is 1 to 2 to 1. Okay? Any questions? Yeah.
What if you were to do one calculation for each element?
I'm not sure I understand. How would you
Like,
do
I'm
that?
questioning the tutorial center yesterday because they said to write one equation for each element to find the molecular weight. And then, so you do that for carbon, hydrogen, oxygen, you add them all together to find the empirical formula mass. And then you do the final molar mass divided by.
I'll have to ask you to explain that to me because I'm not sure what they're telling you.
It's probably way not necessary.
Tutors are very useful, and
Yeah.
the tutors at the tutorial center are trained, but they are students, okay? And they sometimes give less than ideal, well, frankly, sometimes they tell you wrong stuff, okay? And so
I think
that's,
it would work, but it's just a different approach.
yeah, and sometimes it's just a different approach, but that's why I really encourage you to ask me questions and to stick around in lab and ask me questions because I have a master's degree and I do more, I know more than the tutors. Let's look at one more. Butane is a compound containing carbon and hydrogen used as a fuel in butane lighters. Its empirical formula is C2H5. Its molar mass is 58.12 grams per mole. Find its molecular formula. So we want to find out how many of these fit into the actual molecular formula. So to find N, it's the molar mass divided by the mass of the empirical formula. Okay, so the mass of the empirical formula, we've got C2H5. So 2 times the mass of carbon plus 5 times the mass of hydrogen. So 2 times 12.01 plus 5 times 1.008, 29.06. You can write that as grams equals 1 mole, or that's grams per mole of that empirical formula. The molar mass is given, I'm jumping around here, 58.12 grams per mole. Divide that by the mass of the empirical formula that we calculated. The units cancel. 58.12 divided by 29.06. This time it comes out, my calculator actually just says 2. So what's the molecular formula then? C4H10. And you can check this by calculating the mass of this formula. If you calculate this, you're going to get 58.12 or really close to it. Any questions?